Good day, class. This is Mr. Adewale, your chemistry teacher. Today we are going to be considering oxidation and reduction. Reduction and oxidation, that's redox. Reduction and oxidation. Okay, so what is oxidation? So we have definition of oxidation in three ways. We have defined oxidation, number one, in terms of addition and removal of hydrogen and oxygen. So in terms of addition and removal of oxygen and hydrogen, oxidation is the addition of oxygen and the removal of hydrogen. In terms of oxidation number, oxidation is the increase in oxidation number. And in terms of electron transfer, oxidation is the loss of electron. You must know the three definitions of oxidation is the addition of oxygen, removal of hydrogen. When you see that there is an increase in oxygen, oxidation has taken place. When you see that there is an increase in oxygen number, oxygen has taken place. When you see that there is a loss of electron in terms of electron transfer, oxidation has also taken place. And the reverse is the case for reduction. Reduction is the addition of hydrogen, removal of oxygen. Reduction is the decrease in oxidation number. Reduction is the gain of electron in terms of electron transfer. So you should note those definitions, they will help you a lot. Now, when we talk about oxidation, then we have a reducing agent and oxidizing agent. A reducing agent is a species in a redox situation, that's in a reduction and oxidation equation. We have reducing agent and oxidation and oxidizing agent. So how do you identify a reducing agent and an oxidizing agent? A reducing agent is a species that is always oxidized, and an oxidizing agent is a species that is always reduced in a redox equation. A reducing agent is a species that is always oxidized in a redox situation, while an oxidizing agent is a species that is always reduced in a redox equation. So note that. So we're going to have some equations now. So we are so so we have some equations right on the board. We have to indicate the reducing agent, the oxidizing agent in each of the equations. The oxidizing agent and reducing agent. So we have four. We're going to do two together, then I will expect that you attempt the other two and leave your answer at the comment section. Now let's check it. Please note, each time you are asked to locate or indicate the reducing agent and oxidizing agent, you only check that at the reactant side. We have the reactant side and the product side. You check for the reducing agent and oxidizing agent at the reactant side only. So for the first equation now, you cannot get your reducing agent and oxidizing agent at this end. It's at the reactant side. And how do you know it? We have defined oxidation. So we're going to check them together now. So let's do that together. Now, this is the first equation. Zinc oxide plus carbon monoxide gives zinc, and then carbon 4 oxide. Now, we want to check for the oxidizing agent and reducing. Now, we have said a reducing agent will be oxidized in the course of the reaction, and an oxidizing agent will be reduced. And do not forget that we will only check that at the reactant side. Then how do we check that? Alright, when we check oxidation number, the best way, let's look for the oxidation number now. Now, you will know it that any element or molecule in a free state, the oxidation number is always zero. I think you are aware of that. Alright, so let's check for zinc here. What's the oxidation number of zinc here? Alright, let's check it. The way we do it, zinc oxide. Zinc, we want to check zinc. Oxidation number of oxygen is -2. -2 equals 0. So zinc will be what? +2. So zinc here is +2. I hope you got it. You will find we are looking for the oxidation number of zinc. So zinc, oxygen is always -2. Oxidation number of oxygen is that's how you see oxygen, you put 2 minus on it. The oxidation number of oxygen is always -2. So -2 equals 0. Then you get, so zinc is +2 now. Please note it. But here at the other end, it has become 0. In a free state, oxidation number of any element will be 0. So from +2 to 0. Is that an increase? No, it's a decrease. Now it's a decrease. So it has not increased. So that is not oxidation, it's a reduction. It has been reduced. Zinc has been reduced. So, and which species is always reduced? An oxidizing agent is always reduced. It has been reduced. So this is a reduction. It has been reduced from +2 to what? To 0. So it has been reduced. So it's an oxidizer. So that means the oxidizing agent is what? Is zinc oxide, because it has been reduced in the course of the reaction. So invariably the reducing agent is the other species, and that's the carbon monoxide. So I've told you it's only at the reactant side. This is the oxidizing agent because it has been reduced. Then this is the reducing agent because it will have been oxidized. Let's check if it's oxidized. Let's confirm that now. Now, this carbon 2 oxide, carbon monoxide is carbon 2 oxide. So that means it's plus 2 here, carbon 2 oxide, plus 2. That carbon here is plus 2. If you check here, this is carbon 4 oxide. This is plus 4, carbon 4 oxide. So you can see it has increased. It has increased plus from plus 2 to plus 4. It has increased. There's an increase there. So that's a species that is always oxidized. That's an oxidation now. That's always oxidized is the reducing agent. I hope it's clear to you now. So this has decreased. That means it has been reduced. That's a reduction. Reduction. It has increased. That's what? Oxidation. Oxidation. So I hope this is very clear. Please check it well. See what we have done. Check it well. It's very simple. Just pay attention. Go through this video. Listen to it again. Check it well. Then we'll do the second one now. We'll do the second one. Now let's take another one. The second one. So I'll take C now. I'll do D, the last one now. D, I'll do it for us as the second one because it's peculiar. It has only one product. It has only one product. So I'll do that again. Then I will leave B and C for you. So we have two. That's iron chloride. Iron 2 chloride plus chlorine gas gives iron 3 chloride. So we want to get the reducing species and the oxidizing agent. Oxidizing species. Now look at this. This is iron 2. If you want to check it, FeCl2. Chlorine is always minus 1. So Fe plus minus 1 times 2 equals 0. Fe minus 2 equals 0. Fe is what? Plus 2. So this is plus 2. Now, and this is iron 3. Invariably, you have seen it. Iron here is 3. Now, chlorine here is 0. In a free state, chlorine is 0. Chlorine here will be minus 1. You check it, chlorine here is minus 1. So check it, but once you have got one species, you have gotten a species, you can get the other one. Plus 2, move to plus 3. That's an increase. Plus 2 to what? Plus 3. That's oxidation, increase. Oxidation. Oxidation. Now from 0 to minus 1. Chlorine here, if you check it, is minus 1. FeCl3. Now F is plus 3 plus 3 plus Cl times 3 will be 0. So 3Cl will be what? Minus 3. Cl will be minus 3 over 3. That's minus 1. So from 0 to minus 1 is a decrease. That's decrease. And that's what? A reduction. Reduction. So now, but don't forget, this has oxidized now. The species that is oxidized is what? The reducing agent. So reducing agent now. Reducing agent. The species, check our definitions again. The species that has been oxidized has increased is the reducing agent. That's FeCl2. While the oxidizing agent is the species that has been reduced. Now from 0 to minus 1 is a reduction and it's there. So that's Cl2. I hope that is clear. Please check it well. It's very simple. Check it well. Whether you have one product or two products, it's still the same thing. I hope this is very clear to you. So I will leave you with the two questions. That's B and C. So the two equations B and C. So you do well to attempt them. Please do them. Please do them. And then leave your answer in the comment section. I know you will get them. God bless you. So see you next time. Thank you.